Hello everyone and welcome to the Festive Fun Talks with the British Geological Survey. We have 3 fantastic talks for you today, which will be starting shortly. We are recording today's session, so please bear that in mind. These talks are being recorded so we can make them available at a later date for you on our YouTube channel. During the talks, please feel free to ask any questions you have via the Q&A function, and we will try our best to answer as many of them as we can at the end of the session. Without further ado, I'm going to introduce you to Dr. Gemma Richardson and Dr. Kieran Beggan. Thank you.
Hello. As Eloise said, my name's Gemma and I'm one of the space weather forecasters at the British Geological Survey. Kieran has helped me put this together and will be around at the end for any questions, but I'm going to give the talk right now. So this talk is all about how we can help Santa to stay safe while he's delivering his packages on Christmas Eve from the potential hazards of space weather. So before he sets off on Christmas Eve, Father Christmas has to think about lots of different things. So on his checklist are things like the list. So has he made it? Has he checked it twice? Has he definitely got all the boys and girls from around the world listed on it? Then he also checks his outfit. He checks that it's clean and tidy and that it still fits. And of course that there's space for all of the mince pies that he's bound to eat on his journey. Then he also checks the sleigh, that it's been well maintained and is flight ready. And of course the presents. So he makes sure that all the presents are wrapped and ready and then loaded into the sleigh in the right order so that he can find them easily while he sets off, while he delivers them to the all the boys and girls. So he also checks the reindeer. Are they ready to fly? Are they fit and healthy? Has Rudolph got his nose ready so in case it's needed? And then of course he checks the weather. And unlike us, where we only check maybe the weather where we are or where we're going, obviously Santa's covering the whole world. So he has to check the weather everywhere. And he checks whether it's going to rain somewhere. So he might need to cover the presents up and keep them dry. Whether it's likely to be foggy, so we'll definitely need Rudolph's nose, or even if it's going to be windy, so he might have to change his flight plans slightly to make sure he doesn't get blown off course. But what about space weather? Does he think about it? Well, I assure you he does. But what is space weather? So just to give you a little bit of background, it's a term that describes basically everything that happens in space that might affect us here on Earth, or any of our technology in the near Earth space, or even astronauts. And space weather is dominated by activity on the sun. So this plot on the right here is an image taken from a satellite looking at the sun using a special filter to let us see the surface of the sun and all the activity on it, as well as a little bit of the sun's corona, which is a bit like the sun's atmosphere. So on this image, you can see there's some bright spots, and they are sunspots, and that's where we tend to get solar flares on. And if you look carefully, there's a really bright spot just in the lower left, which is a solar flare in progress. So it's a really bright release of energy from the sun. So how might space weather affect us here at Earth? Well, as you can see from this image made by the European Space Agency, we have the sun at the top, and I assure you this is not to scale. The sun is definitely further away than this. And the sun releases a few different things in our direction as well as light. So one of those is solar energetic protons. So these are really energetic, positively charged particles that fly out through space towards us here at Earth. And there are also solar flares, and those solar flares bring radiation with them. And then this last one here is a coronal mass ejection. So that's like a huge bubble of superheated charged gas that gets exploded out from the surface of the sun, and that contains charged particles and it contains some of the sun's magnetic field. So all 3 of those different things from the sun travel out through space, and if Earth happens to get in the way of them, they can affect things like the satellites, which you might imagine, given satellites are in space. And satellites can get damaged, so either by the radiation or by these charged particles. And sometimes these charged particles can cause little short circuits inside the satellites and make it look like they've been given a command when they haven't been. So that can cause a bit of a headache for the people operating the satellites from the ground, because then they have to work out what the satellite thinks it's been told to do and stop it doing it usually. Then if we move a little bit further down into the kind of upper atmosphere, you can see there's lots of disturbances that happen in this region called the ionosphere. So it's around kind of 110 kilometers upwards in the atmosphere. And those disturbances can cause electric currents to flow, but it can also cause errors in navigation and difficulties communicating with satellites. Then if we move down a little bit further into the atmosphere, around the kind of altitude that aeroplanes fly, and coincidentally Father Christmas flies, then the main risk there is being exposed to radiation, particularly from these solar flare events. And then lastly, right down at the Earth, so on the ground, if we get one of those coronal mass ejections, that can cause what's called a geomagnetic storm, which can induce electric fields in the ground, which causes electric currents to flow. And they won't hurt us, but they can flow in things like power grids and pipelines. So how might any of this actually affect Santa himself? Well, the first thing is navigation. So Santa's very prepared, and he tends to have lots of different methods for navigation. And he sets up a GPS route, but GPS can be really badly affected if there's one of these space weather events happening at the time, because those signals can't get from the GPS to the ground very well, and it can just make them really inaccurate. So it's important that Santa knows that it might not be as accurate as on a quiet day. And then also, if he wants to rely on kind of old school maps, if there's a geomagnetic storm going on, then the compass will vary wildly and it won't point north. So that will, again, makes navigation a bit trickier. Now, that's not a problem for Santa because he's a very clever man and he has lots of different ways of navigating, but it's important that he knows that they're not accurate, so he doesn't rely on them too much if there's a space weather event going on. The next thing is communication. Obviously, Santa checks in with his elves back at the North Pole every so often. But again, during a space weather event, communication can get disrupted. So there might be issues with some of the satellites that enable communication, and also high frequency radio. So again, it's not too big an issue for Santa, as long as he knows that, you know, if he has trouble getting through, if it's because of space weather, as long as he knows that, he's not going to panic. And as I mentioned before, at the altitude he flies at, radiation can be a problem if there's a big solar flare. But there are ways around this. So the radiation really only affects the polar regions during one of these solar flare events. So as long as he designs his route so that he spends a little bit less time in the polar regions, and then when he really has to be near the poles, like when he goes home, he can fly at a lower altitude, and then he'll be safe and keep his reindeer safe as well, which is most important. Okay, and another thing that might get affected is NORAD. So you may have come across NORAD, and it's the North American defense system that normally provides air warning of missile launches, but on Christmas Eve they have a very special job, and they track Santa's journey and they make that public so that we can all see how far he's got and how he's getting on and how many presents he's delivered. Again, all their satellite systems can be affected during space weather, and there can be difficulties with precision and knowing exactly where he is. So again, they need to know if there's a problem with space weather, firstly, so that they don't worry if they lose sight of Santa briefly, and also so they don't mistake him for a missile, because that would be very bad indeed. The last kind of space weather effect that I mentioned before was electrical currents flowing in the ground might cause problems. Now, these don't cause problems directly for Santa, but they can disrupt power networks, and in the past have caused power blackouts, which of course means in terms of navigation, if he's looking for some really obvious landmarks based on the lights, because most cities now stand out so brightly because they're all lit up, he might not be able to see them if there was a power blackout. And also the other issue with power blackouts is nowadays lots of people's house alarms go off. So that wakes people up. And the last thing Santa wants is to suddenly have everybody waking up just as he's trying to deliver his presents. So one of our jobs is to work with power grid operators to understand the risk from space weather to their power grids, to try and make sure that even during a big geomagnetic storm, they can keep the power on. And that's very important. So how do we help Santa directly? Well, as I said at the start, I'm one of a team of forecasters who watch the sun and issue regular space weather forecasts like the ones shown on the right. And we make those available to the public, so you can find them at that website at the top. Or we also tweet regularly at BGS Space Weather. And if there's going to be aurora that you might see in the UK, we also tweet at BGS Aurora Alert. So we've got lots of experience of looking at the sun and trying to understand the space weather and forecasting it. So what we do for Christmas Eve is we work together with forecasters around the world to make sure we've got the complete picture, so we can tell Santa exactly what he might encounter so he can prepare for everything. In the last few years, as you can see from these tweets on the right, our Christmas Eve forecast has been pretty much quiet. A few years ago, there was a small chance of some activity, but it didn't really amount to anything. But that's partly because solar activity works on an 11-year cycle. And we've just entered a new solar cycle called Solar Cycle 25. So we're starting to see a slight increase in activity. So we're getting more solar flares and more coronal mass ejections. So in the next few years, Santa's going to have to start thinking about space weather a bit more carefully again, because it's been a little while since he's had to. But once he's been fully prepared and he knows what he's going to face, he can just sit back and really enjoy watching the Northern Lights. And just to add in a few extra pictures, just because they're so pretty, here you go. So thank you very much for listening. If, as Eloise said, if you have any questions, pop them in the question and answer, and we'll answer them later for you. So now I will hand you over to Paul.
Thank you very much indeed. I'm just going to share my slides with you. I confess to being a regular consumer of your tweets. So it's nice to put the personality behind the information. Right, good afternoon, everybody. I hope you're in the festive spirit. You can see I didn't bother dressing up for this afternoon, just my normal workday clothes. Doesn't everybody wear a waistcoat and a bow tie for work? So I decided I was going to look at the geology of the Holy Land and a little bit beyond, because I'm a firm believer that Christmas really does rock. This is the Mappa Mundi, the map of the world, and you can see it. Well, when we're allowed to travel around, you can see it in Hereford Cathedral. It's a map which has Jerusalem in its center. And it's not really a map that you would use to navigate. Gemma's GPS is much better for that. But it's a map that, as you go away from the center, things become less and less important. And the UK does feature on that map, but perhaps not as prominently as we might like to think. And the other bit of advice I've got, if you do go to Hereford, is do make sure that you see the map. And don't forget to visit the adjacent tea shop. I've got fond memories of taking my son there some time ago now. So if you know your story, your Christmas story, and if you listen in to one of the carol services over Christmas, no doubt this passage from the Gospel of Luke will be read out. It came to pass that there went out a decree from Caesar Augustus. Some things don't change, that all the world should be taxed. And all went to be taxed, each to his own city. So Joseph went from his city in Galilee. So let me just find my pointer. So Joseph went from Nazareth up here all the way down to Bethlehem in order to pay his taxes. And the reason he had to go back to there is because his family line, his family tree goes right the way back to David. And David is from Bethlehem, and that's why he had to go there. Now, coming with him was Mary, to whom he was engaged. It was his espoused wife, who was pretty far gone in being pregnant. And when they got to Bethlehem, well, it was time for the baby to make its appearance in the world. And when the baby was born, he was wrapped in swaddling clothes and laid in a manger. And we'll come back to the baby and the manger later on. But really, this is the area that we're looking at. We've got the Mediterranean over here on the west. We've got the Dead Sea down here. And this is more or less the area that I'm going to be looking at in the next few minutes. But I do want to sort of blow a few myths apart. The background slides we've got make prominent use of snow and ice. You may know the carol In the Bleak Midwinter. Well, I'm really sorry to tell you that frozen oxidane, which is the proper name for water, isn't a feature of December in the heights of Judea. The weather at the moment in Bethlehem is a mild 11 to 12 degrees. There might be a little bit of rainfall, but it generally does not snow in that part of the world in the way that our Christmas cards may like us to think that they do. So we'll come back to oxidane again towards the end, but I'm delighted that the snowman is well wrapped up, has got his festive hat on, and is ready to dig himself out of any snow drifts should they come his way. Another thing that I want to highlight, and if you watch the introductory taster video that Leanne, the next speaker, gave you about Brussels sprouts and so on, well, the film A White Christmas is a festive favorite, and you can see the singers and actors in the picture with snow. Well, that white stuff isn't snow. It's actually asbestos, which is a dangerous white mineral that's been made to look like snow in the film studio. Asbestos is a particularly horrible kind of mineral whose dangers cannot be overemphasized. There's a friend of mine, a guy called Nick Cooper, who is a member of the Council of the Geological Society, the professional body for geologists. And Nick developed a set of activities on geology for Cub Scouts. And I've run it locally at my Cub Pack 2 or 3 times now. And the first question when I walk through the door carrying big boxes of rock samples is, have you got any obsidian, mister? Cub Scouts are very polite, hence the mist of it. And obviously, if you know your Minecraft, you'll know why obsidian is of such interest. Well, obsidian is this glassy, fresh igneous rock that breaks in these kind of curved conchoidal shapes. But the problem is there's not a lot of it around in the Holy Land. There are archaeological finds near the coast of the Mediterranean, and the obsidian here comes from 2 places in what would have been Asia Minor, and then moving into some of the former Soviet republics. And so there was a really strong trade in obsidian from where it was produced to where eventually it was used. So no obsidian, I'm afraid. Now, I've had the privilege over the years to travel around the world and work in many different countries. And when I get sent to a new place and I know nothing about it, I begin at the beginning by asking myself, well, what is the plate tectonic setting of the place that I'm going to? So the place we're looking at today is down here. And we can see these white lines mark the boundaries between the big plates that the Earth is subdivided in. So we can see that there is, in fact, a plate boundary that goes right through the middle of our area of interest. Okay, let's see if we can learn a bit more about that. So if we zoom into the Eastern Mediterranean, We can see Cyprus, we can see Greece, we can see Turkey. And rather than colouring in the terrain by national boundaries or even rock types, we see that the colours are chunks of geology that are separated by major faults. In essence, what we've got in the green is stuff that's being squeezed out from the east, where India smashes into Asia. And what we see in the Middle East, in the Holy Land area that we're looking at here, is this vertical north-south line, which is labeled the Dead Sea Fault. Now, I should say, while I've got Cyprus on the map, that my interest in the geology of the Holy Land developed a long time ago when I was working in Cyprus for the Geological Survey. And this year, it's going to be a strange Christmas because we're discouraged from seeing all of our friends and all of our loved ones. And we're kind of hunkering down and keeping the groups as small as we can. But my year spent working for the Geological Survey at Christmas time gave me the opposite problem. I had so many friends, so many relatives, that who would I offend by not spending Christmas with them? So I couldn't answer that question. So I decided to do the only sensible thing you could do, which is to leave Cyprus. And I flew across to Tel Aviv and spent my time on my own exploring Jerusalem and Bethlehem and the Dead Sea and so on. So that's where the inspiration of my interest and the inspiration of this talk came from. Now, I've mentioned the Dead Sea, and geologists like cake. And we like cake because it's tasty, but it's also a very good model for some of the simpler geological conditions that you find. And so here we see the layers of the cake on the Mediterranean side and on the Jordan side. And then here we've got the Dead Sea. Now the Dead Sea is really weird. It's very deep. It's really salty. You don't want to open your eyes underwater. I didn't do that, but I did dunk my head underwater. And when I came up and opened my eyes, the ultra salty water got into my eyes. And I can tell you it was a very painful experience. But what you see is that the Dead Sea sits in a basin, in a bowl, into which some of the youngest sediments have been deposited. Now, the BGS PowerPoint template has a number of standard slides, and this one is labeled that it's a divider slide. And so that rather appealed to my sense of humor, and you'll see whether that's any good or not in the next slide. But the picture shows you three types of faults, surfaces along which movement has taken place. A normal fault is where things have pulled apart. A reverse fault is where they've shortened, they've slid over each other. And then the third one is where things have slid past each other, a strike-slip fault. So you've got three types of fault. And well, it's not my fault if these jokes slide past you unnoticed. So this is a divider slide. If you look at the terrain of the Holy Land, you've got the Mediterranean off to the east. You've got the hills of Judea, where the shepherds were minding their flocks. You've then got the valley in which the Jordan flows, and we've got the Dead Sea down here. And then on the other side, you've got the uplands of Jordan itself. Now, when I was an undergraduate student, I was being taught tectonics. James Jackson, Professor James Jackson, was explaining his research in Greece at the time. And he said, you need to ask yourself questions like, why is the lake there? And the question is, well, why is the Dead Sea there? So let's go back to the faulting. So this is a different type of divider slide. We're back in the Mediterranean. We can see the big Anatolian structures that essentially allow crushed material from India smashing into Asia to escape to the west. And then we've got the Dead Sea Fault, which you can see on this image down here. And what's happening is that we've got movement as two sides of the Dead Sea, of the Jordan Valley, slide past each other. Now, this cartoon shows just sliding. It doesn't explain why we've got this deep linear basing, this deep linear hole in the ground that fills up with sea. The water evaporates, it gets much saltier, and we call it the Dead Sea. And the reason is in the diagram off to the right. As this movement takes place, if there's a little kink in that line, and nature hasn't taken a Stanley knife to carve out a perfectly straight line, if there's a little kink, as the movement proceeds, you begin to open up a void, a hole. And as the movement proceeds, that hole gets bigger and longer, and eventually it will fill up with water, which will evaporate in the heat and give you the Dead Sea. So the Dead Sea is a structure called a pull-apart basin. So we now know why the lake is there. Let's go back to Joseph and Mary as good taxpayers. This is a Thomas Cook guide or a Dorling and Kindersley guide from the 1500s. It's a woodcut map showing how the area may have appeared in the time of the baby being born in the manger. We can see the Mediterranean, we can see the River Jordan and the Dead Sea, we can see some of the uplands over here, and on the other side of the Jordan over in what is now the country of Jordan. And so Mary and Joseph, heavily pregnant Mary and Joseph, move from Galilee down towards Jerusalem. And the terrain that they would have been walking over, or hopefully Mary would have been riding on a donkey, slightly more comfortable than walking. And you can see the geology here. There's Jerusalem. We can see the valley is infilled with relatively young alluvial deposits, but the hills on either side are a mixture of limestones, sandstones of different ages, layered pretty much horizontally in large parts of the country, as the younger rocks lie over the older rocks. So relatively simple geology, but you really notice that the geology on either side of the Jordan, on either side of that strike-slip fault, is very different. These things don't match up. And the reason is, of course, because we've got sliding. So they wouldn't match up. And that's good evidence that the model I showed you earlier is in fact correct. And what we see is that the terrain, the lay of the land, reflects the geology and the tectonic setting, the fact that we've got this major dividing slide of the Dead Sea Fault. Now, if we zoom in to Jerusalem and Bethlehem, this is a geological map of the area, and what we see, here's Jerusalem, and nearby we've got Bethlehem. We look at the geology in a very simple form. The yellow is wind-blown silty soils, loess-type soils, the sort of soils that got Fred Shotton very excited when he found them in Normandy, and he was recommending where the D-Day landing should take place. But that's a different story altogether. We've got the greenish deposits. I'm not sure if the colors come out very well. And then the brown deposits, which are the limestones that we'll come back to when we look at Bethlehem in detail and see where Mary ended up. Now, the geology matters to a country. It provides us with natural resources. It provides us with the clays and the sands and the gravels we need. It provides us with minerals, and it provides us with water, back to the oxidane. So here we see the hydrogeological map of the area that we're interested in. And it's a reminder that a lot of our drinking water comes from the ground. And in particular, it comes from rocks that are either fractured or soluble, and the water's dissolved away the rock so that there's more space in the ground to hold the water, the oxidane that's stored in there. It's not only water that gets stored in those kind of rocks, though. This part of the world is showing having tremendous interest for hydrocarbon exploration. South of the shores of Cyprus, there is something called the Eratosthenes Seamount. If you don't know who Eratosthenes is, then it's a good thing to look up as you're waiting perhaps for Christmas lunch to appear. So off the coast of the Mediterranean, we have large areas where the geology is just right for oil or gas to be trapped. And we'll come back to this towards the end of the lecture, but just suffice to say that the geology is supporting the economy, but also providing threats to the quality of life that we want. So in summary, the geology of the Holy Land is dominated by the strike-slip fault that runs south to north, forming the Dead Sea as a pull-apart basin. But like much of the Eastern Mediterranean, a lot of the area is underlain by limestone, which is good for storing water. And offshore, we have hydrocarbon resources. So as you munch on your mince pie, sing on that Christmas carol, as you enjoy the wonders of what took place in Bethlehem 2,000 years ago, don't forget the ground on, or indeed in which they took place. Got 3 more slides to go, but I thought I'd give you a commercial break. This is a new project that BGS is involved in, and it's not so much about using geologists to hold up big lumps of rock, but it's about encouraging girls to get into studying the geosciences and engineering. So if you want to know more about that, then have a look at ngproject.eu. Right, enough of the commercial break. Back to Bethlehem. We can see the Church of the Nativity over the place where the baby was born. And I've used this image from 2010 because it shows you the hills around Jerusalem shown quite nicely on the terrain in this particular map. So we've got Bethlehem on relatively high ground, and then it's a relatively sprawling development over the last couple of thousand years. But let's look at the Church of the Nativity itself in the next picture. So here we see the hills depicted in kind of diagrammatic form, and the Church of the Nativity down here. So when on Christmas Eve you see the pictures from Bethlehem, that's the church that you'll be looking at. It's an area that's been of considerable interest. We saw the Thomas Cook Guide from the 1500s. The map on the right, published in the 1880s in London, shows you the geology. And again, you see the difference either side of that north-south Dead Sea fault, reminding us that things are sliding past each other. And if we go down into the Church of the Nativity, you can see that you've gone down some depth. And you can see this lady is kneeling, worshipping the place where the baby was laid to rest in swaddling clothes. Now, what I like about this picture isn't so much the ornate marble and decoration and ornamentation that's been added to over the years. You can just see on the right-hand side, very plain, very boring limestone rock, easily excavatable, exploited at the time in order to create space for storage, for keeping animals safe, and so on. And this is where the baby whose birthday we're celebrating next week would have been laid for shelter and protection. So, whichever language you speak, happy Christmas. And you've got a range of languages there, which I'm not even going to try and read or pronounce, so I just get it wrong. But a final thought going back to those hydrocarbons in the Eastern Mediterranean. And I only put this slide in about an hour ago. 2 hours ago, the Archbishop of Canterbury, who you may hear over the next week or so, celebrating the birth of Jesus, wishing the Pope, one of whose titles is God's Vicar on Earth, the Archbishop of Canterbury wishing the Pope a happy birthday, because it is indeed today Pope Francis's birthday. So that reminded me of a letter that Pope Francis wrote in 2015 called Laudato Si. And in that letter, the Pope reminds us that climate change is real and mainly a result of human activity. And he quotes St. Francis of Assisi, God's Pauper, if you know the book written by the man who also wrote Zorbas the Greek, Nikos Kazantzakis, a Greek Nobel laureate. St. Francis says, praise his Lord, praise God through our sister, Mother Earth, who sustains us and produces the various fruits that we eat. But there is nothing new under the sun, because if you go back to the book of Ezekiel, written well before a baby was born in a manger in Bethlehem, you'll see these words. Is it not enough for you to feed on the good pasture? Must you also trample the rest of your pasture with your feet? Is it not enough for you to drink clear water? Must you also muddy the rest with your feet? And this kind of enshrines environmental geology and environmental management in 4 lines. And that's what I spend most of my time doing in my working day. So I'm going to leave you with that thought and wish you a merry Christ Mass, a merry birthday of Christ, and a happy new year. And I'm now going to hand you over to Leanne, who may well talk to us about meals.
Thank you very much, Paul. That was very interesting. So I'm going to talk to you a little bit now about food and Christmas dinners. So I'll start with some of the things that we have on our Christmas dinner table. And I'd also like you to have a think about an answer to put in the chat, which is, what do you think tinsel is made of? There are several answers that you can have as correct, but I'll be intrigued to see what you put in the chat. So tinsel, I'm sure we've all got it on our Christmas tree. What's tinsel made from? But I'll start with one of my favourite things that you tend to start with before you tuck in, because you need to do your obligatory Christmas hat so you can have your Christmas dinner. Geology and Christmas crackers. It's a bit tenuous, but believe it or not, if you can't obviously grow it, then you've got to find it in the ground, and it needs a geologist. And the snap in your Christmas cracker is made from a material called silver fulminate, and silver fulminate is quite explosive. It comes from galena, which is a lead. So this is an example of galena. You can see that it's quite shiny, it's quite heavy. In its more commonly found form, it can just be as a small bit of ore in a larger host rock. This is a piece from Derbyshire, where lead mining used to happen, but they're actually mining the fluoride in this instance, and lead was a byproduct. And alongside the lead, you often find silver, which was also mined in the Derbyshire Dales. And when you apply pressure to silver fulminate, it can explode. Even the touch of a feather can explode a pile of silver fulminate. If you get too much of it, it can explode even under its own weight. So when you rub 2 strips of it against one another, it will definitely explode. So if I pull this, and the friction will cause a small bang, which you can probably just see there, and there was a small amount of flame, and now I can smell the smoke of the explosion. So without geologists, there will be no snap in your Christmas cracker, which wouldn't quite be the same. Next thing on our Christmas dinner table, we've done the formalities, let's dig in. You probably have maybe some of these on your Christmas dinner, but more often this is the vegetable most closely associated with Christmas. It's your sprouts. And we do grow these in Britain. They grow very well in our climate. And in order to grow things commercially in this country, we often put fertilizer on the fields. And that fertilizer can be in the form of potassium salts. Plants really need potassium to grow. And we actually have quite a bit of this fertilizer that we use in a geological form that's buried under the North Sea. And there are mines up near Whitby or Bulby that have in the past mined potash, which got its name from the non-geological version of the fertilizer. It was the ashes that the wood ashes on the fire that they would soak the potassium out of. But the potash that was mined in Bulby was a geological version, and then they've moved on to a potassium-rich fertilizer that they mine in Bulby called polyhalite. Now this is halite or rock salt, and this is a sort of salt that you could put on your chips or grit the roads with. And polyhalite is mined almost a mile underground and about a mile under the North Sea as well. So the miners that excavate this material work in conditions often over 40 degrees Celsius, and they can really dehydrate because it's a very dry atmosphere full of salt. So they have about 4 litres of water in a cool box that they have to drink throughout the day. So just to get the fertilizers that they can put on the fields to make sure our Christmas vegetables grow nicely and make sure we can have tasty Christmas vegetables on our table. So that's your geological link to your sprouts. And now I'm going to move on to something a little bit less geologically linked, and that's some of the Christmas tipples you might have on your dinner table. Now, one of the ones that the UK is famous for is whiskey. Most often Scotland is famous for it, but there are single malts produced in Wales, Northern Ireland and England, but they're obviously more famously in Scotland. And you get several different things go into making a whiskey. You've got the grain and the malt that can give it the flavour. You've got whether or not you dry that with peat and give it a smoky peated flavour to the whiskey. You've got the water, which is an important component. In fact, the name whiskey comes from the term ushkabar, which is water of life, and that got shortened to ushka, which got changed into whiskey. So this water of life is a huge component of part of the whiskey. And the last one of the last few things is the barrels it's stored in can give it its flavour, and the shape of the copper stills that it's distilled in can really have an effect on the way that the whiskey matures. And obviously copper is a geological element. It comes from malachite, which is a rock. We have malachite in North Wales, in Anglesey. It's not actively mined there, but it did used to be. We used to have huge volumes of copper produced from Anglesey to coat the bottoms of our ships to send goods overseas. So what happens with water for when it's used to produce whiskey? Well, water often comes from the rain to begin with, and when it falls on the ground, it can do several things. So it can soak through layers of peat and soil before it gets to the underlying rocks, or it can land directly on a bare rock. So it could land directly on something like this. This is a granite. It's not a Scottish granite, but it's just a really nice example, or a nice example of a granitic rock to demonstrate. And if water lands on a rock like this, it would pretty much run straight off. I could demonstrate, but it will get messy. So it wouldn't have much chance to absorb many of the minerals and become a hard water. It would run straight off and either go straight into the rivers and then be collected by whichever distillery is using it. Or if there are some cracks in it, it could go into the cracks in the rock and be stored in that way, just like Paul was saying in the talk earlier about limestone having lots of these holes for water to be stored in. So some of the best whiskies apparently are from granitic rocks. However, there's not actually that many distilleries cited on granite. I can show you a map in a little bit if you want to have a nosy around and put in the chat some of your favourite whiskies. I'll try and find the distillery on the map and you can have a look at which rocks it's cited on. There's a few near Speyside on the Ben Rhines granite, but more often they're cited on schist, and this is a mica schist, a very nice example of a mica schist, the shiny bits on the mica, and sometimes the rock can take a little bit longer. It can take a little bit longer for the water to percolate through the rock, and when that happens, it can pick up some of the minerals, especially if it's in a calcareous sandstone. Some of the whiskies, Old Putney, for example, in the north of Scotland, they percolate through sandstones and can become quite calcareous. And when you've got a hard water, it absorbs fewer flavour molecules. So what happens there is the distilleries often choose to peat their whiskies so that it can have the peated flavour as the strong component rather than the more subtle flavours of the Speysides that are made from soft water, and therefore you can get slightly more from the original grain. So there's the three main rock types in Speyside, as I've gone through the granite, and then a large area we've got sammites and peelites and schists, and then in the north you've got some sandstones on the coast, and then there's some quartzites. This is just an example of quartz, which you sometimes find veined in amongst the quartzites. So all of those, the water runs off pretty quick, and you get a nice soft water that's not full of minerals. It's not a hard water. So if I have a look at this map, I will share it with you. You share my screen, and I can have, so we've got some answers already, so questions already as to where the different rock types. Oh, it's just made the question disappear. So before it disappeared, I could see that someone had asked where Talisker was. I'll go to Speyside. Talisker or Speyside. This is picking on my knowledge of whiskies. Why can't I see Talisker? Well, I did see Dalwhinnie. I'm going to go back to that. So I don't know if you can see my pointer. If you can't, then about in the centre of the screen, just slightly to the east of a pink blob, you can see you've got the Dalwhinnie distillery, which is within the Grampian Highlands. So that's between, there's the Highland Boundary Fault and the Great Highland Boundary Fault in the south east, and then the Great Glen Fault, the one that Loch Ness is in the northwest, and it's sort of bordered between those, and that's within these sammite rocks. So that's within the rocks that the water will percolate through relatively quickly. Now, how can I see the
Looking for Talisker, it's a heavenly whiskey on Skye.
Skye, okay.
Told you my jokes weren't very good.
There we go. It's on the very west there, and that's on some of the sedimentary rocks. So is it quite a peated whiskey? I think I'm missing out here. There's quite a supply of peat, as you may be able to see on the maps. That's the brown polygons on top. And where there was a supply of thick peat, the distilleries would use that to their advantage, and they would burn it to dry off their malts quicker as well. So on these very wet Western Isles, the reason the whiskies are often peated is because, again, they can take advantage of those sources of heat to artificially dry them and give them that smoky flavour. But I'll go back into the Speyside area. You've got Ben Rhines, which is on the granite, but very few others get their source water in Speyside from granitic rocks, even though it's kind of seems to be championed as the type of rock to get your whiskey from. And then in the centre of the screen now, there is a map of English and Welsh whiskies. You've got a couple of distilleries in Wales. These are all distilleries that are active. So to appear on the map, they have to be producing whiskey that you could go in the shop and buy right now. So there's no closed down ones here. These are all ones that are actively producing. So you've got an Adnams, a few in London, which is interesting because they'll have very hard water. You've got a White Peak distillery, which again, it's on sandstone. So that might be a fairly mineralized water. And then Penderyn in South Wales, which is a limestone that it's filtered through. So you've got one up in the lakes on some metasedimentary rocks, so that might be a slightly softer water, so it would be interesting to know what that tasted like. But so there's just an example of some of your English whiskies, and then some of the not. You've got Old Putney and some of the Highlands and Islands whiskies up there. Let me go back to the chat so I can see if anybody had put a different distiller in. Right. Dalwhinnie, we've done that one. Cotswold single malt. Had I put that one on the map? Yep, so that one was on the map. That's again, limestone, the lovely Ulitic limestones from the Cotswolds, made up of very small, lots of very round, small grain. This is an Ulitic limestone, so that would be what your Cotswold whiskey had filtered through. Talisker on Skye, yep. Any last requests for zooming to an area that produces whiskey? I'll give it a couple of seconds. Oban. So Oban is definitely on this one. On the metasedimentary mudstones that have been squeezed slightly. So that's not on. Not going to be as softer water. That's going to be a slightly harder water. But I do know that Oban gets their water source from the mains. Their mains water is that good quality that they just draw their water source directly from the tap water. It's great. There's no point trying to source your own borehole if the tap water is excellent.
And tell them about Bushmills.
Orkney. Sorry, what was that?
Tell them about Bushmills.
Bushmills in Northern
Ireland. Yeah.
And that one again is in the same as Oban, so that's in your metamorphic sandstones and siltstones. So slightly softer. Orkney Islands. Yep, so we've got Highland Park and Scapa are produced in Orkney, and they are some sandstones again with lots of joints in, so they might be a slightly harder water, so maybe they're a peated whiskey. So isn't the colour that you often get from whiskey, so you've got a Penderyn here and a Glenfarclas, so a Speyside and a South Wales, isn't from the water. It's not to do with the water, it's often to do with the barrels it's stored in, more than the length of time it's been matured, more than the water that goes into contributing it. But the one thing that is certain for all whiskies is the best way to have your whiskey, possibly controversial opinion, isn't just neat as it is. It's to add a few drops of soft water, so not like this East Midlands water I'm using here, to open up the flavours, and that will mean that your whiskey can spread around and release the flavour compounds a bit more. So there were a few of different whiskey locations. There are a few different things that you might get on your Christmas dinner table, and there were some good answers for tinsel. So tinsel originally was made of silver, correct? They also used copper until for the First World War, when they needed copper for war purposes. And then they changed to aluminium, which is from bauxite. This is an example of bauxite here. And now, quite disappointingly, like pretty much everything in our society, it's made from PVC. It's made from plastic, which you still need a geologist to find the crude oil, but it's made of plastic. I'll hand back to Eloise in case we've got any questions, and thanks very much for listening.
Thank you, Leanne, and actually thank you to everybody that's delivered a talk today. That's been fantastic. So we're now going to go to the Q&A and read through any questions that you've sent in for us. So if you haven't done so already, please do send those in. Okay, so one of the first questions we've got is, on the assumption that Santa is travelling at a hypersonic speed, how do the reindeers and sleigh cope with the sonic wavefronts? Do I have a volunteer to answer this one?
I think you need a physicist for that, not a geologist.
Oh, you can give it a go.
I can answer that if you want. So I think it's obviously magic that is the reason why Santa can travel so fast. But I think maybe what you're referring to is the fact that the atmosphere gets a bit disturbed during space weather, big space weather events. But actually that's much higher up. That's above sort of a few 100 kilometers where it gets really disturbed. Down kind of around the altitudes that Santa flies, where the airplanes are, that will tend not to get very disturbed by space weather. So he's probably safe enough as he is traveling at hypersonic speed, even during a geomagnetic storm, I think, given whatever his technology or magic that he uses to do it at the moment.
Thank you, Kieran. So another question that we've got is, what kind of rock will the mud in the Dead Sea become once the Dead Sea dries up? I know we have had a couple of responses in the Q&A, but I thought it was worth reading out for everybody.
Let me take that one. I'm essentially going to say what Leanne wrote in the answer while I was talking, which is when you evaporate the water, what you get left behind is the crystals of whatever was dissolved in the water. You get salt, the stuff you put on your fish and chips. You get gypsum, calcium sulfate, the stuff that plasterboard is made out of, and you get calcium carbonate, the stuff that limestone and chalk is made out of. And in the answers, I've said that if you go to Cheshire, you'll see the birthplace of the chemical industry because it needed chlorine. And if you go to Saltwich and Northwich, you'll see areas that have been affected by salt subsidence. And if you go to Ripon, you can go to an area where development is constrained because of gypsum dissolution. And BGS's Tony Cooper is the person who worked most closely with the local authority to protect development from gypsum in Ripon.
Fantastic, thank you, Paul. So I think that's all the questions we've got at the moment in the Q&A. So I'm just going to leave it a couple more seconds to see if anything else comes through. Is there anything else any of the speakers want to say before we head off?
I think Clive asked if there was a distillery in Cornwall, and yes, there's Healy's, which produce whiskey as well as cider.
Fab, thanks. So if there isn't anything else, I'm going to wait a couple more seconds for anything in the Q&A. No, if there's nothing else coming in, if you do have any more questions, please do send them in, and we'll try and get back to you as soon as we can. So now we've run out of time. I want to say a huge thank you to all of our speakers today and to everyone in the virtual audience. I'm wishing you all a very Merry Christmas and a Happy New Year from the BGS, and I hope to see you soon.